Hi, everybody. Yeah, I'm Ritesh Mukherjee from Nokia. I work on SROS and SR Linux, which is the operating systems we have. I'm a product manager. My team, we do product management for routing, telemetry, and some other stuff, but that's what I do. Today, I'm not here to talk about that. I'm going to talk about some security issues with BGP and why we need to do better as a community. And also, I'm going to talk about a tool, an open source tool, not related to Nokia, but of course, I work in Nokia, so I'm talking about it. But it's an open source tool which you can use. I'm not the only contributor on the tool now. There are some European operators, tier 1 operators who have contributed to the tool. It's an open source tool, so they can contribute. And that is live. You can go see it on GitHub and, of course, see who's contributed. And it's not a secret. You can figure it out who they are. One more thing before I begin, sharing is caring. When we talk about security, we need to share experiences. So I talk about many incidents to sort of make my points before I show the demo against smart logic. I decided to show a live demo, so I'm going to try it out, connected with the Wi-Fi of the hotel, but should be okay. But having said that, sharing is caring. I teach at Northeastern. It's a university in the US in Boston. I teach cybersecurity to grad students. And the one thing we tell them is sharing is caring. If you don't tell us what happened, we will never be able to learn from it and not do it again. Sort of fix it and not repeat the same mistakes. So the names of the parties, when I talk about it in the examples, it's not like who's good, who's bad, who did right, who did wrong. That's not the point. The point is we learn from that experience and we use it to not have the same problems again. So when UK traffic takes an unplanned detour, it happens. It happens quite often. Providers or operators 3 ASs away from you can affect your traffic. And they can route traffic mainly because the way BGP was designed, the way internet came up and the way BGP was designed, everything was based on best effort. Everyone told each other where they are, how to send routes and so on. Everybody believed it and sent packets along, which was great until some people figured out that, hey, I can create my own messages and I can create false messages and move things around the way I want it to, thereby disrupting the global internet. And we will talk about that with some examples. June 6th, 2019, 70,000 routes are leaked from a data center provider in the Switzerland. And that traffic from 3 major operators in Europe, Swisscom in Switzerland, KPN in Netherlands, and Burgess in France. They all start routing traffic via Beijing. So any packet takes a 20,000 kilometer detour and comes back. No one figures it out. Everything's working. The BGP tables look good. Control plane looks good. Everything looks good on the net until people figure out the latency issues. When people realize why is it taking such a long time. They figure it out after some time. It takes 2 hours to figure out what has happened and nobody notices. We should be able to figure these things out in seconds. It should not take us such a long time. Definitely not such a long time to realize that we have to wait for customers to call us and say, hey, your network is lagging. Definitely not that long. And we'll talk about it. The thing that people will say is, oh, it was a misconfiguration. It was embarrassing. We get it, Ritesh. It happened. Let's not repeat it. Well, these are not rare events. It's a pattern. And I'm only talking about 3, but there are so many. I could keep listing it and have the whole day just talk about different incidents. 2019, the China Telecom route leak, which I'm gonna talk in more details about these. 70,000 routes leaked, 2-hour outage. In 2020, Rostelecom, 8,000 prefixes hijacked. Google, Facebook, Amazon are all down for customers. 2024, this one is a little more concerning. The reason is people did have RPKI and route origin validation, which I'm going to talk about in detail. They had it deployed and still Cloudflare, many of you might recognize 1.1.1, Anycast DNS IP address, one of the most popular addresses on the planet, was hijacked, 300 networks down, in 70 countries affected, and people can't get to where they want to, even with some of the validations done. These are not rare events. These happen regularly, including till recent. Even last month, Telegram was down because of a mistake in RPKI again. These keep happening, and we need to make sure they don't. Why does it matter to anyone in this room? Obviously, UK is a large peering point. The way the internet is, the cables are laid out, a lot of traffic travels through UK. Whether we like it or not, one of the biggest ISPs is here. They're touching every continent, traffic from every continent. And so you are in the blast radius. Even if you are doing business in Europe, you have never talked to these countries, you have never had a business relationship with them, they can affect your routing. So you need to be careful. Route servers, obviously, any route servers, LINX hosts, they are protected because they have got obviously blocks on them. But your bilateral sessions, that's up to you to sort of protect and deploy validations. And a leak anywhere obviously puts you in the path. Like I said, you can be 3 ASs away in a country which you have never done business with, and they can affect routing for you and divert your traffic. So what are the things we can do? And what I'm trying to get to is the way BGP is designed, Border Gateway Protocol, it's a best effort. It came up, everyone started saying, hey, I'm here, announcements saying I'm here, this is the path to get to me, and so on. The world grew, and the internet grew. We just believed all the advertisements we get. Obviously now, we can't do that. So we need to have some checks, what we call route origin validation. But there are some things which we can't really sort of solve by just doing one protocol or one single thing on the net. For example, route leaks. You can validate who's the origin. There is RPKI registries. RIPE is hosting one of them. I'm going to connect to them live and show you demos. But they have registries which say, hey, I am the origin. Anyone can go and register and say, I'm the origin. Well, that doesn't mean you know what path to reach the origin is correct. Anyone can say, I am the origin. Tomorrow, someone can say from the US that, hey, I am a European provider, and traffic will start routing to them. You can't really stop that, what path it's taking. So we need not only route origin validation, we need ASPA, which is AS provider authorization. Someone can manipulate the path the packets are taking, just like, it can take a 20,000 kilometer hop. Yes, someone can manipulate the path to take a wrong path to reach you. And of course, they might not even reach you. They might drop the traffic, do anything with the traffic. So you are in the blind. Stealthy attacks. Someone can divert the traffic. Someone who's not validating in the middle can divert traffic or drop traffic, and you wouldn't know about it. These are gaps which we need to sort of plug. So how can we plug these gaps? The most basic is to do route origin validation. Validate the origin. So if you look at the diagram, it basically says, and if an attacker announces that, hey, I own 1.1.0/24, which is Cloudflare's 1.1.1 address, if your router doesn't check without rove, it validates it, it believes it, that, hey, 1.1 is located there. But if you have route origin validation, then obviously, as you can see, your router says, no, that's invalid. You are not allowed to announce this prefix. And only Cloudflare can announce it, and your router validates it. The good part is this exists today. It's been deployed. The only problem is only 51% of IPv4 addresses or ASs are doing it, and 57% of IPv6. We crossed 50%, which is great, which means half of the internet is not validating. So anyone in the middle who's not validating, connected to you or on the path, can sort of be diverted, or their traffic can be diverted through that. The other is we need to validate the path. If anyone says, hey, I am 1.1 or .1 and I'm located here, you need to validate the path. There is a way to do that, and it's coming up. It's called ASPA, AS Provider Authorizations. Basically, it monitors. Everyone says, hey, I am the origin, and this is my upstream providers. You continue down that path, you find out the path, and you take the correct path. So it's like a mountain. Instead of you go up the mountain and you come down to the next customer. If there is a valley, which means someone in the middle says, diverts the traffic, then you know that is not the correct path. And this exists today. The problem is only 1% of ASs have signed ASPA objects and registered ASPA objects. So pretty much 99% of the internet is not doing it today, so anyone could divert traffic. And we'll go through some examples of how people have done it. And finally, BMP. One of the questions I get is, yeah, okay, Ritesh, we need to do RPKI, we need to do ASPA. When is your router going to support it? You have not done it. Well, we are working on it. It's not that we are not. But you don't need to wait for us. You don't need to wait for us or any other routing vendor. Yes, the routing vendors are all not ready. You don't need to wait for them. You have BMP today. BMP is available on every router, or 90% of the routers. It's been around since 2016. It tells you what messages your routers are getting. From the adjacent ribbon, I know what my peers are sending me. If they're sending me any update, I know that. I can take it to a collector, I can verify it today. I don't have to wait for my routers, my routing vendor to do anything. I don't need to even modify my routers. I can figure this out independently today, and I'm going to show it in a demo that I have. But with this, we should be able to block any or many issues which we are seeing today. Let's go over some of the incidents which we talked about and see why they happened, so that we can sort of figure out how to stop them. I'm good on time. So what really happened in 2019 which diverted the traffic? Safehost, data center in Switzerland, they misconfigured a BGP session. Happens all the time. You make a mistake, you don't have the proper route filters or the explicit policies, you leak routes. So their prefixes, they leaked about 70,000 customer prefixes to China Telecom's Frankfurt POP. Happens, it's a mistake, misconfiguration, they leaked all the addresses. China Telecom, they themselves had not done any filtering, they themselves leaked those addresses as well. So now, even if you had valid addresses, those addresses are now on the global internet table. So to reach any of these addresses, the world is thinking, I need to send packets to China Telecom and back. So any traffic which now from Swisscom, KPN, and Burgess, any traffic is being sent to them is being routed via Beijing. Common mistake, but no way to figure it out. The operators took 2 hours to figure it out with manual intervention. There was no automated detection until people saw some latency spikes and realized, hey, we need to sort of figure it out, why this is happening. You make a lot of phone calls, and you figure it out finally how to block this traffic. Let's talk about the 3 things I talked about. Would they have helped in this case? RPKI, or route origin validation, it would have partially helped. Why? Well, many of those prefixes are valid. People would say, these are valid prefixes. What's the problem if I'm getting it? You wouldn't see any issues with it. So partially it would help. In some cases it would catch it, in some cases it wouldn't. ASPA, which is validating the path, that would definitely catch this. It would say, no, this is not the valid path to reach this. China Telecom is not the upstream provider for Swisscom. They are all tier 1 ISPs. They are not in a hierarchy provider-customer relationship. You would figure it out. I don't need to send my packets to Beijing and back. So it would definitely have caught it. The sad part is only 1.1% of the planet is doing it now, so, or 1% of the planet is doing it now, so we have some time before it can be used. BMP would definitely figure it out. You would suddenly get all these unexpected routes from China Telecom. You would validate it. You would validate it against RPKI and RIPE's routing information source, and you would alert it in seconds. Let's look at the Cloudflare hijack, the 1.1.1 hijack, which happened in 24. What happened in this case? A hijacker announced a more specific prefix for Cloudflare's anycast address. Instead of 1.1.1/32, they announced a more specific prefix, which made it look like a valid prefix, and so it appears legitimate. One of the ISPs on the path, Peer 1, they were not really validating, and so they also propagated this, and so it spread through non-validating neighbors. Ultimately, DNS traffic is silently diverted. Anyone who's using 1.1.1 for DNS, you guys are smart. You guys will go to your computer and change it to 8.8.8, and you're good with it. You're like, DNS had a problem. I fixed it. I'm good. But most of the people on the planet don't know how to do that. They are just going to Facebook.com and not able to reach it. Amazon.com, not able to reach it. They're like, this doesn't work. My ISP is not that good. So the BGP table looks fine. The traffic is gone, and you are unable to sort of reach your destinations. It's more like a stealthy attack. Let's see how this would look. So the BGP table looks good. In this case, everything looks valid. RPKI, origin validation, looks valid. Origin is valid. Cloudflare is 1.1.1. It is registered. It's a more specific address, but it's registered. It's valid. But if you do a trace route 6 hops away, you can see your traffic is not going to where it wanted to. That's because the path is wrong. The point is that you don't have to be directly connected. You could have done everything right in your network, and still you could be affected. What would the layers do? The 3 things I talked about, would they be able to catch this? Origin validation, it would miss it because it would say this is a valid origin. This is a more specific route, but it's valid. ASPA depends on the coverage. If everyone registers and everyone had registered on the path, yeah, in those cases it would catch it. But many cases we know ASPA is not, everyone is not covered, so they would not be able to figure out the path. So it would be not caught. BMP, yes, BMP would figure it out. You would get this new advertisement from your adjacent ribbon. You would know that this is, you would validate it against RIPE, global view, and see that there is a divergence. You would know that, hey, this is not correct. It would catch this. The point is, no single tool can sort of catch everything. We need all these 3 to work together to sort of figure out why we are missing some routes, where the routes are, and if the routes are taking a correct path or not. Origin validation, ASPA, and BMP, together they tell us all the things we need to know. Now let me go and show a tool which can do all of these things 3 together. And this tool is open source. It's a single binary. It correlates BMP feeds from any router. It doesn't have to be a Nokia router. It doesn't have to be a Cisco, Juniper. It can be any router, Arista, FRR, any router from anybody who has BMP. It takes BMP and it validates it against live feeds from RPKI and ASPA from the registries, from RN, RIPE, and others. And it alerts you immediately if there is an anomaly. If there's any origin change, if there are any ASPA violations, if there's any anomalous paths, and so on. It's available, that's the address, it's available online. You can go download it, use it, and so on. The demo I'm going to show you, I have Container Lab running on this machine. I just started it before, of course, before the presentation, and I tested it. I have 4 routers in the demo, the green, the blue, and the orange. It's supposed to be red, but orange. They're acting as internet, upstream, and edge routers, and the red one or the orange one is acting as an attacker. So what I'm going to do, I'm going to show you a baseline, what the routing table looks like, and then I'm going to do some attacks from the attacker to change routes and so on to create a leak and a hijack and show you whether it can catch it or not. Raven is getting BMP feeds from the two routers, the two blue routers. It's monitoring what those two routers are receiving, and it's also getting RPKI data live from Arin and Ripe through Routinator, and it's correlating them to say whether this is valid or not. So if it's in your network, you can deploy it today, or maybe on a laptop or server or wherever you want, and you can get feeds from BMP feeds from your edge routers and validate if the edges are sending you the right data or not, and what that data is. And of course, I have CLI and some Grafana dashboards to show you what I'm gonna see. So right now, what the routes look like. So if you look like this is what Raven is seeing currently. It's seeing all these IPv4 and v6 routes. It's validating already. It's telling me who's the origin. If our ROV stands for, of course, route origin validation. It's telling me which of these are valid, which of these are ASPA unknown, and what is the posture. So if you look at it today, it's saying pretty much everything is valid except for one, which is on purpose. I have added a route which is not found. Otherwise, it looks like everything is valid. But these are all ASs which have valid origins and which have registered with RIPE, and they are sending that data. I'm validating it. Unknown, obviously, the world is ASPA coverage is poor today, so it's all unknown because it's saying none of these are ASPA valid. I have a dashboard I built in Grafana, which is pretty much showing me all the BGP POs are up, the BMP sessions are up. I am getting 950K validated payloads from RIPE, and Routinator is connected. These are the 9 routes. One of them is unverified. Everything else is 0. So what I'm going to do now is go and create an attack. So what it's So what it's doing now, it's creating a live attack from the attacker, and it's creating a invalid origin session. It's announcing AS64496, which is invalid, and so I should see it live in my route table, obviously, as you can see now, I have a new entry which says, I received this entry, one of your routers, the two routers which have received BMP, they tell me, I am receiving this route. And Raven takes that route and says, hey, validates it and says, no, this is invalid. You are not supposed to take this route. This is invalid. Someone is saying they are who they should not be. I can go into my dashboard. If I refresh it, you can see it now says you have one invalid route. What this tells me is I can today do validation on any origin validation and ASPA coverage, ASPA validation on any of my routers without really making any changes to my routers. I can do it independently. I'm going to go back and remove that hijack which I had done and do an ASPA attack, obviously. So I'm going to create a route leak. So this is using a valid origin, but a wrong path. So now I'm going to see AS1199 is an ASPA provider set. It's going to have a valid origin, but a wrong path. So if I go now and see my routing table, you can see it says there's a new entry, which origin is valid, But as per the path is invalid. The path is not correct. So this is a path suspect. And if I go back to my dashboard, you can see now path suspect is 1, origin is 0. Obviously, I removed it. The only reason I show the dashboard is you can sort of integrate it with a webhook to alert your NOC or your Slack channels or your text messages. You'll get immediately a message saying someone's trying to do something which is not valid on the internet connected to your routers. I'm going to go and remove the leak and do the same thing with IPv6. You can see now I have an IPv6 which is saying origin invalid. I only implemented IPv6 because as soon as I showed it to an operator, a tier 1 operator, they said that, do you have IPv6? And I was like, I just started doing this. And they were like, we're not going to try it if you don't have IPv6. So I immediately went and immediately I implemented IPv6. And of course, now they have trialed it in their labs. One of the cool things that they did, it's a large tier 1 in Europe. One of the cool things they did is they wanted to use it because they obviously, someone in the US suddenly announced that they are the operator, and so their traffic was diverted. So because of that incident, they wanted to really be aware of all this. But one of the cool things they had is they had the BMP feeds during that time. So in their lab, they put Raven up and they ran those BGP feeds to see if it would catch it or not, and it did. So it was pretty cool to see that. But the idea is the tool is available today. You can go try it out. You can even contribute to it if you want to, and we can see what works. Does the tool do everything? Quite frankly, there's no tool which does everything. So no, it doesn't. What can it not do? A hijack by your legitimate upstream provider. If you are sending your traffic to your upstream provider and they take your traffic and they black hole it or move it around, you can't do anything about it. They are your trusted legitimate upstream provider. They are trusted by design. This is designed to sort of just follow what they are doing. Attacks that happen before ASPA and origin validation data propagates globally. The tool is verifying what is coming to you with what is there in the registries, what the 5 registries have got. It's verifying against that. If the objects are not registered, it just shows, like I said, it shows unknown. It can't really validate unless someone has registered it or set the path. Compromised RPKI validator infrastructure. This is more recent. We're starting to see, just like, someone can poison DNS, the same way someone could poison the validators themselves. Is it possible? It's probably possible. I'm doing some tests with the Raven tool and some new enhancements I'm doing to sort of see how we can figure that out or be resilient. But having said that, if the RPKI validator itself is compromised, obviously, the data you're getting is wrong. Encrypted traffic interception during legitimate transit. If you're saying that this is going to secure everything, well, the word secure is loose. It's going to route everything correctly. Whether that traffic is secure depends on other things you have done with that traffic. There's no security unless everything is done correctly. So what should we do about this, you might ask? It depends on where you are in the matrix. I sort of have a graph which says, yeah, you should create origin authorizations first. It takes 15-20 minutes to do it. There's no reason why tomorrow you shouldn't do it if you have already not done it. Sign ASPA objects. Even if you have not enabled ASPA, you should declare who your upstream providers are. There's no reason for you not to do that. People will start, the more we do it, the more people can validate, and the more the registries know, and then everything works well. Close your blind spots. Validate everything, especially for bilateral peers. If you're connected via route servers, which LINX is hosting or someone else is hosting, they have probably got a lot of filters done already. If not, you should be doing it. BMP anomaly detection. There's no reason why you should not be configuring BMP on your routers and using it to validate. It can figure out many other things as well. 3 layers, stack them and use them. Rove, ASPA, BMP, and of course, cover your blind spots. Any questions? Even if you stayed up late watching the match, you gotta wake up. Go ahead.
You mentioned with the Cloudflare, when that leaked. You said when Cloudflare leaked, that was a /32. I thought the majority of routers doing IPv4 would reject anything that was smaller than /24. So how did that kick in?
That's the thing. You're right. If everyone had done it, if everyone had done it correctly, you're right. You should not accept any prefixes on the global routing table, which is smaller than a /32. That's true. But some ISPs in the path had not done it, which is why it happened. It's unfortunate. Everyone, it's the same thing, right? Even if you do everything right, if someone else doesn't, you can affect the global routing table. Unfortunately, yeah.
Any more questions? I do have one quick question. Have you thrown the full internet table at it yet, and have you found anything exciting?
The exciting part is I do see ASPA coverage growing and rapidly. Like every time I try it out, every couple of days I run a demo or something or do something, I see the ASPA coverage growing up. It's growing much faster than how RPKI grew. So I do see that, and that's because people are registering their ASPA objects and so on. So the relationship is building faster. I do expect within a year or maybe even less, we should have a good coverage, which is exciting. What I don't see is protection for the RPKI infrastructure itself, in the sense, what if you are asking RN for an object, what if someone in the middle changes that object or gives you a false object, or if your RPKI validator itself is corrupted, what would you do in that case? Those things are sort of not covered, but they are TBD kind of discussions, yeah.
Okay. Thank you very much.
Thank you.